the algebra tiles are set up in our textbook. The yellows in the textbook are positives, the red in the textbook are negatives. Now, if they don't have colors and it's on a blank piece of paper, how do you know who's positive or negative? They've got to give you a legend. This would be considered a legend. Now, if they're positive and negative on a separate piece of paper, on black and white, you might have shaded, they might have shaded B positive, and they might have white B negative. Now, they could change that on you. They often change it back and forth. So don't always get used to saying, okay, well, the shaded's positive or shaded's negative, because they will change it on you. Okay? You have to know which is which according to the situation you're told, okay? So, lesson 1B, we're going to model with algebra tiles. Let's take a look at what they look like. We need to know what sizes of the object they are, okay? So the sizes matter. These big boxes right here, those are our x squared boxes. So on your page, these ones are the x squareds, okay? The long skinny sticks, they stand for the x's, and the little baby squares, they stand for the 1 unit, okay? Over here, same thing. I've got x squared, x, and a 1 unit. Again, because I'm using red and yellow, red is negative, okay? So here it wants to know, what would I draw to represent the x squared plusing 5? What would you draw there? What color would they be? Oh, don't forget, we can't forget these are our negative signs. Negatives, negatives, negatives. All right, yep. Good, so a big square, and then 5 little baby ones. Okay? So you guys draw 5 baby squares and 1 big square, okay? Try and model the other 2, okay? You guys draw them and see what you get. Okay, let's take a look at what you got. I've got 2 a squareds. So that means I'm going to have 2 positive boxes. Oh my goodness, not the x squared. I want my positive boxes. There we go. Okay, so I got 2x squareds. Then I've got my 4n. What's my long skinny sticks? So I'm going to long skinny stick. I'm going to have 4 of them. Okay, and how many little baby ones do I have? 6. I have 6. What color are they going to be this time? They're going to be red. Good. Okay, that's what you guys should have drawn. Now again, if you wanted to, you should just put plus signs inside them and negative signs in the ones that are shaded, okay? On the bottom here, what should we have had down here? 2 of them, right? 2 big ones. Where's my big ones? There they are. 2 really big ones. And then what else do I need? 3 little sticks. Good. 3 red sticks. Do we have any constants in this kind? Those little baby squares. Do we have any constants in this one? No. We don't see a number without a variable there. Okay, that's how we would draw those. Check your work. Okay, here's a partner activity for you. It says partner A models a polynomial using the algebra tiles, and partner B writes your polynomial down. Then you're going to reverse it, okay? All right, let's give these a try. Taking a look, this one says, which ones can be represented by the same algebra tiles? Well, this is just showing us the one concept here. It does not matter the order they're written in. The color of the object and the size of the object must matter. So, for example, on the first one, letter A, if I were to draw letter A, I would have 4 big yellow boxes. Okay, so here's letter A. I have 4 big yellow boxes. Let's try and find out in B and C. Do I get 4 yellow boxes out of B and C? Which one in the letter B tells me if I'm going to get big boxes or not? With the squared, right? This one right here. So that's 4n squared, and it's a positive. So would they be 4 yellow boxes? Yeah, they would. What about the very bottom one here? The 4p squared. Would those be positive 4 yellow boxes? Yes. Okay, so far right now, we know that those ones would match. Now we're going to try and find our long skinny sticks. All right. How many long skinny sticks do I have up here on the first one? 6 red ones. I have 6 negatives up here. Whoa, not that one. These guys. Okay. What about this guy down here on letter B? How many sticks do I get on B?
It's only 5. You messed up there.
Did I really? Oh,
Yeah.
I pulled another one over, didn't I? Thank you. Okay, on B, you only get 3. Good. What color are these ones?
Yellow.
Yellow. Good. So I'm going to get 3 yellows on this one. What do I get on the very last one? 6 reds. Which one's telling you in letter C to do 6 red? Right, the one with the variable, the one with the letter. So here I'm going to have 6 reds. So this guy has 6 reds. So far, which one's matched so far? Whoops. A and C so far. All right, let's check and see if the very last one matches. So how many little baby boxes would I have in A? I would have 3 baby ones. So I would have a 1, a 2, and I would have a 3. Okay, 3 baby boxes. How many baby boxes do I get on B? 6. What color?
Red.
Red. 6 red ones. So if I take a look over here, I got 6 little red ones coming over here. Is that what I'm looking for to match? No, they don't match so far. Let's take a look at C. How many little baby boxes do I have? I have 3. What color?
Yellow.
They're yellow. Good. So which ones end up matching completely? A and C end up matching completely. Okay. Now, what did they do different on letter B? How did they make it different? What did they confuse to think it was the same? What did they do? Right, they switched the places of the 3 and the 6. Okay, that's all they did here. So, or we could say that they actually put the N with the wrong number. The N, if it was going to match A and B, should be with the 6, so I have 6 red sticks. Okay, and then the 3 would be by itself to give me 3 little baby boxes. So what they did was they completely mixed those 2 up. Okay, let's take a look at another example. These ones, is it a mono, bi, or tri? Let's take a look at what this would look like here for us. Negative 2n squared. What's that telling me to draw? What should you draw for negative 2n squared? Good. 2 big red ones. All right, 2 big red ones. Is that all I draw with that one? Yes. There's no sticks on that guy, and there's no baby boxes. If I've only got that, what do we call this? Is this a monomial, binomial, trinomial? What kind is this one? It's a monomial, good. And we can tell just by looking at the digits and the letters. They're all grouped together sitting side by side. So this one's going to be a monomial. Okay, that guy's a monomial. What about the next one? What about B? What about B? It's a trinomial, you're right. But the other way we can tell is by drawing the objects. The different sizes of objects tell you the kind it is. If you take a look at A, I've only got one type of object, right? They're both identical, but there's only one kind. They're only big boxes. Okay? So because of that, only one kind, it's a monomial. If I look at B, I'm going to get 3 big boxes. Then I'm going to get a red, long, skinny stick. Now I've got 2 things different sizes. And then I've got 8 little baby ones. So how many different sizes of objects do I have here? 3 different sizes. I've got 3 different sizes. What do you know about that? It's a trinomial. That means it's 3 terms. So this guy's a trinomial. There's 3 different terms, which means 3 different sizes of my object. Okay? Different sizes of the object. You got big long sticks, you got big boxes, and then you get small baby squares. What about letter C? What do I have for letter C? What would I draw there? What would you draw on C? What kind of objects do I have in letter C? Do I have big boxes? Do I have sticks, or do I have baby squares? Do I have baby squares and sticks? So I've got 5 long skinny sticks that are yellow. And then I get 10 negative red ones. So I get 10 little baby red ones. So how many different size of objects do I have here? Two different size of objects. So if I have two different size of objects, what kind of a polynomial is this one? It's a binomial. Good. Okay, so make sure you have that written down. On this one, we have to write what we see. So on this one, now we need to have what's called the symbol representation, not the area diagram. This is actually called symbols. Symbols are what we see. Okay, what we see right now, those are called our diagram. We want to see symbols. Symbols are just numbers and letters. So what would these two red ones give me here? How would I draw that in numbers and letters?
Negative 2x.
Good, negative 2x squared. What do all these long yellow sticks give me? What does that all give me?
Plus 5x.
Plus 5x. Good. You got to put that plus sign there. That's super important. Okay? We know they're positive, but if you're going to sit it side by side with those x squared, you've got to put a plus sign between. What do we have at the very end there? Minus 3. Good, because we have those red little squares. All right, you guys write down what you get for B and C. Okay, let's take a look. Again, you start with the largest object. So here our largest object on B will be our sticks. So I'm going to have 5 sticks, so 5 x's. Okay? Now, again, he's starting at the front, so will I have to show his hidden plus sign? No, not if he's starting the expression. Okay, what am I going to put right after him? I'm going to put all my baby squares. How many do I have? 6. Good. So minus 6. What do you do with the bottom one? Who do you start with? Good. Negative 2x squared. You're going to start with the really big ones. Then you go to the medium size, which is your long skinny sticks. How many of those do you have? Good. Can I just put 5x like that? No. What do I got to do? Put the plus sign between them. Good. What do I have at the very end? Negative 3. Good. Your negative 3 little baby red squares. All right. That concludes lesson 3.1b. That will be your assignment.
Made a tree.